Hello friends, welcome back. This is Somnath, and today's topic is how Git works behind the scene. So what Git is actually, right? It's basically a version control system, we know. And if you are a beginners or maybe never used Git, probably this video will help you out to understand the very basic insights about how Git works, the different mechanisms that Git uses to store the files inside its repository or maybe its own database system. So my overall intention in this video is to just give you certain ideas which probably been overlooked because all the things been abstracted at a high level and we don't care about how those things actually get managed internally. So kind of a file storage, what are the different algorithms that Git uses to store the files, when you do a commit and kind of a push things from, staging the file contents and moving those files from staging to working directory, etc. So those things we predominantly, taking care of through the GUI interface, some interfaces, and kind of those complexities been hidden right from us, and we just use certain fetch and merge rebase, those kind of calls, and to make our project collaboration done kind of a smooth way. By the way, I mean, if you are not using Git, because probably if you are coming from an ABAP background like me, I assume like you haven't used Git yet because you probably didn't need it, right? In ABAP, we generally do the object transportation from system 1 to system 2 using a transport request. We call it a CTS, right? Connection Transport System. But if you are coming from a different technology background, then obviously I'm sure that you have used Git a lot. So those kind of an experience that you have gained through using Git, probably all kind of at a abstracted level, as just I just explained. So in this video, my intention would be just give you a fair enough idea like how actually Git manages those things within its own own space, or the different technical mechanism that it applies when you do those kind of operations. At least I would say this is quite interesting. So I hope like you'll also enjoy this discussion, and stay tuned till the end. And if you like this video, share it with your friends, colleagues, if probably they can also get benefited out of it. And if you have not subscribed my channel, request would be to subscribe it and set the bell icon to get to intimate this kind of discussion in future. So let's head over to the next thing. Like we'll be installing the Git, and we'll also understand the difference between Git and GitHub. Let's check that first. So the difference between Git and GitHub for the beginners looks like pretty much same. I mean, Git and GitHub both are same, but eventually they are not. Okay, so Git, for you to know, like it's kind of a distributed version control system, because it let's say you are changing a particular node file, .txt file, and obviously you don't track the changes that you are making, right, on that particular file. So if I ask you, like, or maybe you want some previous version of what it was before to get it back, probably it is not an easy task for you unless you store all the files, with a different naming and maybe a kind of a date and timestamp. So in that case, Git basically sounds bit, helps a lot in this version controlling mechanism. So we can just register or maybe say like, hey, this is the file, can you just manage by your own? And Git will just take care of this file and start creating different versions the moment I'm making a changes. So at any point in time, I'm interested for a specific version, I can retrieve from this Git because it stores all the different versions easily. And it's definitely, as I said, like it's kind of a locally installed to your computer, and it doesn't need any internet access, of course, but still you can access pretty much all the kind of features that Git provides. Now, when GitHub comes into picture, let's say you are working in a project and you would like to have this project in a kind of a collaborative way you want to continue, means your maybe colleagues or friends would like to contribute to your project work. So in that case, your Git is not sufficient because it's working locally. So GitHub is kind of an online file repository, some sort of. So obviously, you have to now deploy all your file structures, file information into this GitHub repository, and you need internet access, of course. and your friends or colleagues then pull those project details from GitHub uh, to their local system, provided they have all the credentials, or maybe if it is public then fine, otherwise they would need the credentials to pull all the file artifacts into their local system. And by doing so, the entire file or repository or kind of a project that you were working on, it will be available to them as well, so that they can make the necessary corrections or necessary changes, and they can push it back to the same file system again. So of course the next step would be you from your end to pull that file again back to your project, and you will be able to see the changes that have been made by your colleagues or team members. So that's how the GitHub differs from Git. I hope that this the basic fundamental difference is you understood this pretty well. So the next step would be, let's install this Git software in our local computer and start our journey to understand how Git works. It's really interesting. So now, if you just get into this particular gitscm.com/downloads, Git, this particular web page, you will see this download options where you'll get option to download the software depending on your operating system. I'm working on Windows, so by default it's came up to me. So it's the latest version, and that is 2.30.1. So I have already downloaded the software. So let's open that file first. So now it's in download folder. So let's double click on that. In case you need administrator option, then you can go to right click and go for admin mode. From there you can run this software. So now it will open like this, and I'll click on next. It's pretty easy because it's all wizard options. Make sure like you have this git bash option checked, okay, because we'll be using the git bash command line tool, okay, and to make all our operations through that CLI only. So that's why you have to just make sure this git bash option is checked. Go to the next, and here I have set it as Visual Studio Code Editor because I prefer this ID, and I would also recommend you to select this option here. Next, go to the next page, and here I have selected let git decide. Regarding the master branch name, I don't want to play around. Let's git decide the default, and that way I would like to move forward. And then the recommended option called Git from the command line and also from the third-party software. So this is the recommended way, and I also have selected this option. Let's go to the next page. I have selected the use open SSH radio button. Then you have to select use the open SSL library. Then I selected this option, the first, like check out Windows style, commit Unix style, line endings. The first option I've selected. Again, the default fast forward or merge. There is something new because this one looks like deprecated. So the new is the option that I have to go with. Git credential manager core, like which credential helper you would like to use. So of course, the new one you have to select. I just take this option, enable file system caching. I didn't check the new capabilities, kind of experimental support, because I'm not sure what it can cause the problem or not. So I didn't want to try this option, just make it, because the beta release, so better have not to checked. Finally, you have to just option to click the install button. I already have installed, so I am just clicking on cancel, and yes, I want to cancel. Good. So let's go to the desktop now. So here I'm on the desktop. Let's double click on this Git, maximize it. Let's make it a little bigger so that you can see that. So let's click on Git version, and you see the version that I downloaded and installed in my software, and Git is properly working. So this is a kind of a command line tool which I'll be using throughout this video to perform all sort of different Git operations. Now I am in my desktop and my project folder. So let's create a folder inside this my project. So I'll use mkdir. Start typing. Okay, mkdir, and then let's say give the name of the project like Git project 1. Okay, because I have already a Git project, so I'm just creating this folder. So let's get into that. Git project. Yeah. So one interesting thing is, like, if I put, just kind of a cd change directory and then type a tab button, ideally it will autocomplete. But I have, if I put two tabs consecutively, then I'll see, like, with the same name. If I have multiple, then I'll just see the list, and out of that I can select which one I would like to go into. So now I'm in Git project 1. So now the first thing that we need to start or need to do is we have to make this Git initialized for particular this project or particular this folder rather. So the command for Git initialization is, let's first get into this folder first. So what I'll do is, let's go to desktop, my projects. There is something called Git project 1 we have just created. Let's maximize it. So looks like this folder is completely empty. Of course, we just created. Click on the view tab, and interesting to see my hidden items is checked. So if I could have any hidden items, even I was able to, I'm supposed to see that that elements or that files and folders inside. So it's completely empty. So what next we have to do, we have to initialize this Git, and the command is git init. The moment I'll do it, it says like that empty Git repository, it's initialized. And inside this particular Git project 1 folder or directory, I'm supposed to see something called .git. Let's go to that folder once. And of course, we see this hidden folder. So that means if I just unchecked it, of course, I won't be able to see that. Anyway, for our discussion, and because we are basically trying to understand how Git works, so we'll be just playing around all those hidden files to understand the behind the scene what is happening. So let's check this checkbox out, and I'll see this Git folder back. What next we are going to check is, like, you see there is something called a new branch created because it's initialized, and the branch name is called master. So it's a master branch. Okay, so let's clear this one. And now just to see like what inside this particular folder, if we click on ls command, we don't see anything. I mean, it looks like apparently empty folder, but we have something hidden files. So for that, the command should be ls, then space, then minus la. And you will see that .git now is visible to us. That's great, right? Let's create a particular file now inside this folder. And for that, the command that I'll use is echo. So if I write echo and then let's say hello world, something like that. And what will happen if I click on enter, it will basically print on this terminal itself. You see, hello world. But it didn't actually create anything as such, because quickly I can check the content of this folder and still it is same thing. So no changes. Now if I write something called echo, again like hello world, and I put an greater than sign, and I'm just writing something called file1.txt. So what I'm expecting now, it should create a file of name file1.txt inside this Git project folder, project 1. So let's click on that. It doesn't show anything. Let's check the command ls minus la. Hopefully now I'll be able to see this file1.txt. So now to see the content of the file, the command is basically cat command. Okay, cat file1. So I'm using my tab, and it auto completes the the thing. And now click on enter. It shows the same thing with which I created the file. And of course, if we go to the folder, we'll be able to see the same file there as well. Now we'll do something like, to edit this file, okay, we'll be using an editor, and the best editor in this command line is the nano that I'll just use. And I will also recommend you to use this editor, nano, and file. Again, click on enter. It will open in this editor, and you can see that's hello world inside this, right? So let's add a new line. This is the second line. Okay. So, and thus to save this file, you click on Control X. It will ask for saving. You click on yes, and it's saved. Click on Enter. It will go back to the CLI tool or bash command tool. To check the file content, again file1.txt, and I can see hello world. This is the second line. That's great. So now what next we'll do, we'll add or append rather from the echo command again. So the command is echo. This is the third line. Okay. And instead of this operator, we'll be using double greater than sign because we are not creating a new file, rather we'll be appending to the existing file. So the file name is again file1.txt. It doesn't show anything else. Looks like my command works fine. It didn't put any error. So let's run again the cat command, and we can see all the contents. That's pretty much the first, certain commands that we have seen. We have some command, anything you want to see, like you can put cat minus minus help, and it will open all the different cat option command options, and you can just browse it through like what exactly it's showing, and as per you can just use the different options. Let's clear the console again. And what next we are going to do, so let's understand now like the different file types that Git actually stores inside. Okay, so we'll be doing something called, the first object that it stores is called blob object, and four type of object basically Git stores within. The second one is the tree type of objects. Okay, the third one that it stores is, maybe you can call it as a commit, and the fourth type of object that it stores is basically called I think it will look good then, yeah, annotated tag. Okay, so in this particular video, I'll be just covering this three items to explain all the Git inside, I mean how it works, the operations behind the scene. So now let's get into our Git folder .git. If you just get inside, a lot of different other hidden folders you'll see, and one of the folder is our point of interest, and this is the objects. Inside this object, the default two folders is info and pack, and other than that, no files or other informations you can see over here, right? Only these two particular folders and directories you can see. So what the command to create the blob object is basically git hash object. Okay. So let's now go to our console, and to create a blob object, I will start first creating a blob object, and we'll do this from our command tool. So the command that I'm going to use is echo. Again, let's say hello, this time git. Okay, and then I'll use this pipe command, and we have to just use this particular hash object concept, okay, with an option called std in. So it's a standard input. So what will happen if I just click on enter? It basically offers a hash key value, right? So this hash key value will be generated as a kind of an information which supposed to be stored inside the object repository. But if I click on enter, you see some sort of hash value it returns. It's a 40 characters, and that predominantly a file which is supposed to be there inside the Git repository. So if I just get into cd.git and just see something like ls, we have something called objects, right? So let's get into objects, and again lsla. As I told, like it will be creating this particular command echo hello git with git hash object from standard input, right? So this part, particularly echo git, echo hello git basically is going to print something on the console. So that information I'm moving as an input, as a standard input to this particular git hash object command. So it is supposed to create a entity or kind of a file information, and that has to be stored within this, this objects folder. Okay. But currently I see in it only info and pack, which was the before state of that folder also. Now the thing is to create a file, a blob object, what we have to do is the same command, right, with standard input, but we have to use something called -w. If I click on -w, you see kind of a same hash objects you can see again, right, 4e ending with 4e and starting with 10. But this time, if I just run, let's clear this out first. And if I just run, we are on the same object folder. So let's run the command ls -la. But you can see something now starting with 10, right? So the command we basically used was, I'm just removing again w, right? So that was the hash key that we received earlier. And interestingly, it starts with 10, and the same 10 you can see over here. So some object, some directory got created, which is starting with this particular 10, the first two characters. And if we get inside, let's say cd 10, right? And running ls/la, what will happen? It shows some other content, some sort of hash key value only. It doesn't show any file type or anything, only that hash value. But that you can see rest of the content of this hash key is basically the file information. So let's get into the object now. Yeah, you see the 10 is got created. If I get into this 10, you see that same file information. It's kind of a file that is actually stored. That's great. Now to see the content of this file, which of course this hello git, which eventually uh, created a particular file type which represents by a hash key, where the first two characters becomes a folder, and inside the rest of the hash value you can see as a file name. So how to get the content of the file at this particular state of the file? And you can see the different read operations only you can see right over here. So what we can do is the git cat file is the command. We can put -p and then the hash value. So you can just select this one, hash value, right click, and you can copy and put the file, put that hash value again over here. If I click on enter, you see the same text hello git coming back. That's awesome, right? So we are able to see the content back if we have this particular file details. With the enter hash value, if we can just put back, we'll be able to get the content back. That's pretty interesting. So how the actually information that git stores behind the scene, probably you can get some idea, like it's all stored with this particular hash value concepts. Okay, now what happens is git predominantly use a particular algorithm, call it SHA-1 algorithm. Okay, so it's basically a concept of creating hash value. If you get into the browser, so if you want to get into this browser and just try to generate SHA-1 hash, and if you go to the first one, SHA-1 hash generator online password generator, and this one is the input box. If you put, let's say, hello git, right, you may notice that there is something automatically, some hash values coming up, right? All the hash key. It's actually one-way conversion, means hello git, if we convert into the hash, this is the particular hash value that we'll get. If you put a simple dot inside and after this git text, you see the entire hash key gets changed, right? And remove it, it will come back to the original state. That's pretty good. So let's go to our console and let's clean this out first. And let's type again echo, then hello git, right? And let's type something pipe, and the utility that git uses is basically shum utility, shasum. If you click on that, you see some sort of hash value. You can find it over here, all hexadecimal characters. Now if you go back to the browser and just little bit compare what it's showing, you see that it's starting with E37 ending with FAC, whereas it is starting with 6CF, 06F, sorry, and it is ending with 11D. But for the same text, right, hello git, here also hello git with all capital and small letter. So that means ideally, if this they are using the same utility, same concept, SHA-on, ideally this hash key should have been matched completely, right? But it is not being matched properly. What happened? The problem is, as I told, like if I put a small dot even, it will change that entire hash key, correct? So in our particular echo command, it is containing a new line character, and that's why it is completely showing a different hash value. So if we just change echo minus n, then let's the same thing, hello git, okay? Sorry. And then again the shasam utility. And if I just compare back, I believe now it is the same one, 06F and E11D. You see, same hash value it got created. That's awesome, right? So like what kind of utility that Git uses to generate the different hash value and store it inside the repository. So let's check one more thing. Like I told, like the echo git hash object actually generates a blob object, blob type of files. So let's roll back to our original, command, which is a git cat file minus p option with that hash value starting with 10, because 10 was the directory name and rest of the file name. With that option, if I click on enter, I can see the content of that file. Now if we just make a little change on that p, make it t only. So t means type. You see the type is basically blob type, as I told, like 4 type of objects. So this is the blob type, the way it's stored. So now what we'll do, we use basically standard input to create the echo hello git kind of file inside our git object repository. The same thing we can do as a file itself, because if I just go to, let's say, put a little backup, we created one file called file1.txt, right? So if I just go here and put la, we have something called file1.txt. If I just check file1, what it was inside, we just created all those 3 different line inside this file1.txt. Correct. So now what I'll do, instead of you know uh, using the echo command, uh, we'll be using git hash object command to have this file1 text to be stored as a repository object. So we'll be writing the git, then hash object, then put the file name, sorry, file1, yes, and then put minus w. What will happen? It will write this particular file1 as an hash object inside the object folder of the git.git hidden folder. So just go quickly. We created one object from the echo hello git standard input, and this was created, and no other folder you can see. So now again I'm going here and click on enter. It is telling it is generating a new file altogether and new git, new hash value, my bad. So now it's starting with 1b and ending with 349. So obviously, as I told, like it will going to create one directory which starting with 1b. So let's go there, and you see, of course, it's created 1b, and inside this folder you see the rest of the hash will match with the remaining hash value, right? Yeah, so ending with 349. Perfect. So now if I want to, check the content, we know the command git cat file command -p, and this is my complete hash value. I can copy it and paste it back. You see the same 3 lines I can retrieve if I just know the hash value properly. That's really cool, right? But yeah, I mean, if you just generate it as a file the way I'm doing, then only from this hash value you can retrieve the content, because it's not just a hash value of these 3 lines, remember, right? It basically an hash object, it creates as a file, so both are different. So it doesn't like from hash value you are basically taking the original input. It is not like that. It's actually converting the hash file. I mean, not converting, rather it's basically retrieving the content of the file which is represented by the hash naming. So both are different, because hash is one way conversion. You never can get the original content from a hash value. uh, that's pretty much, and that's the reason it's used for all sort of secure password generation. That's cool. So now if I just see how many folders and files are there within, so cd.git/objects and run the command ls-la. So -la will give you all the hidden files and folder information. Different authorization or kind of access, then the user, and then kind of a file size. I mean, this is not a file size, it's basically something called it as a version. Okay, so it's basically the new version that got created, so it's 0 on that concept, it is 0. Okay, and this is the two folders got created, 10 and 1b. Pretty awesome, right? You can now understood like how the files are getting stored. So the next learning should be, let's learn the tree object, how it actually creates the tree object. Now let's understand what this tree object all about. So what happens currently, we have created two blob objects, right? So the tree will basically contain the pointers of the blob objects. So if I have two files, so one file, we don't have any name of the file yet in the blob object, as we have seen, and we are only having the hash value, right? Hash key. But that is not the complete hash, because the first two characters will be used for the directory. Anyway, I'm just writing it as an hash1, and I'm creating another file, and I'm writing it as hash2, just for the easy of understanding. Now, if this hash1, if we can recall, we probably created this hash1 with some echo command, right? Kind of echo, then use something called hello git, and then we use something, that git hash object -w. So with that option, we basically created this one of the hash object, and kind of a file inside the object repository. And the other hash object, which actually created using the file1.txt, and that time we didn't use this echo command, uh, not this -w, honestly, because it should be having something in between, because I have to say like it should be taking from standard input. So minus minus, stdin. So this one we created all the way through our echo command, and this one we created all the way from the git hash object, like git hash object, and we just put some the file name file1.txt, and finally put -w. So with that we created the another hash object, correct? And now what the interest is, like we'll be creating two pointers, so that it basically points to these two files, okay, from this tree object. And this file doesn't contain the name of this file. It's only the hash value that only I can see as the name. So the name of the file will be stored inside the tree object. So let's see how this tree object looks like. So before getting to the tree object creation, one interesting thing let us note quickly, and that is let's clear it first, or maybe what I can do is, uh, if you can recall, this is the particular hash value which we generated using this this git hash object, and our file was actually file1.txt, and this file was under this particular git project 1 that we know. So let's quickly remove this file. Okay, so what I'll do, I am now in git project master branch, and just check quickly the file availability, and we see that file1.txt does exist. What I'll do, we'll remove this file, remove file.txt, and it basically deleted this file1.txt. So to validate, let's read on this command, and you see it doesn't have any file1.txt available. But if you just check the git object repository, you will see still this particular 10 and 1b, these both folders will be available. Let's validate cd.git/objects. If you run -la, and you see this, both the things are still available. So interestingly, if you just try even to run this git cat file command -p, and you just copy this same hash value, let's copy the same hash value and put this back, what you can expect now, because the original file which actually we moved into the git repository, this file no more does exist in that git project 1 folder. We have just deleted it. So what is the impact on the git object repository? So far we have seen that there is no impact, because this 1b and 10, both the hash, that folders, the directory does exist still. So can I get the content as well? Of course, it is 1b, so that means pointing to this particular directory, and inside that we have this particular file. So let's hit the enter button and see what comes up. You see the same text, original text with which we created this file1.txt. So that means if I remove the file, still it doesn't have any impact with the git object repository, because it manages its own file structure, own file system, or own database. It doesn't have any impact with the working directory as such, because it's already having a different a domain and different file system to manipulate and manage or orchestrate. So it doesn't have anything any impact if I remove the file from the working directory. Different hash value, SHA hash value that we created under the git repository. So for that, the command is find, then dot git/objects -type, and then f. So it basically shows the different SHA-1 hash files that got created. So these two information I'll be using as the pointers for my tree file creation or tree object creation. So what we'll do, using something called nano commands. So you can just write it up somewhere, will be easy. Let's copy this entire thing, and let's run something called nano file tree.txt, and let's paste it back. And the two files basically over here, what we'll do, we'll start with some permission. So the permission code will be 100644, and then put a space, then put blob, then put space, then you have to put the actual hash value. So the hash value should be all with 10, and of course you have to remove this /. So this is my the hash value, and after that what I'll do, we'll put not space, rather a tab, and then give the file name. So I don't know what it was. I think it was the file1 with echo command because it's starting with 10. So file1.txt, or maybe file1 first file. Let's write it first file. Different name, okay? And again, here the same thing we have to do. The permission you have to put 1000644, then blob type object, delete all the things starting from here. So remove everything and just remove the forward slash as well. So we have my blob, second blob object, put tab and put second file .txt. Okay. So then click on Control X and I click on yes, I have saved it. So now this is got created. And now let's put this particular file. Let's put something like, and you see this file3.txt got created, right? So to see the content, simple cat file3, and you see this object got created. So now we'll just see once more this tree object we created, and you know, this tree object we would like to store in our Git repository. So to make this tree object creation, we have to use the command called git mk3. So just quickly see, like cat file tree. So this is the type, or content of this file. We have to put this as an input to a command called git mk3, which eventually will offer a new hash value. So this hash is nothing but the tree object. So if we go into our object folder, we'll see this F4, this particular folder got created. Okay, we can see the content again. F4, by the way, I don't need to type the enter hash. If we just type initial 4, it will, okay, sorry, get my bad, it should be git cat file command -p, and we can put F439. We'll be able to see the content back, and instead of p, if we put -t, what you should expect, of course the type should be tree, and here it is, right? So that's cool. So we have created successfully a tree object which is actually pointing to two different files. So now let's quickly check the different environment, like kind of a git object, git repository. Then we'll check something called staging area and something we have called working directory. So we have put the files inside our git repository. So from that repository, we'll just now retrieve the file into a staging area. So what I wanted to mean is, like, let's clear this content first. So we have currently this particular three areas. Let's just write something this way, and here it is another area. So this one I'm calling it as a git repository. This one I'm calling it as a staging area. Not what incorrect spelling, right? And the last one is working directory. Okay, so currently we have three objects we created. So one is my tree object, right? Another is first file, and another is the second file. So three things are there, and the tree object is actually linking to these two underlined blob objects. So now what we'll do, we'll basically move this particular tree object into our staging area, right? So this file will come over here. So enter file system will be automatically moved into staging areas. So for that, the command is actually git retree command. So let's do that now. So let's clear this content, and we know, like, something we had F439, right? So that was our initial four characters for the SHA-1 hash value for the tree object, and we know this is the type tree. So what we'll do, we'll write git read 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 tree, and we'll put like this F4 39. So we have basically just try to read that information from this against this Git repository, and now the file should be available in staging. How to check that? If you just run this command, like git ls files, you will see now these two files are basically coming inside the staging folder. So I can do something like git ls files -s, and it basically shows the file information in proper way, like only these two files, first file and second file, how these files are all set together, that also the contents I'm able to see. So now from from this Git repository, the file now moved into the staging area. That's pretty cool. So the enter things, file system is now over here, and we have to now just move this particular file information from staging to working directory. And for that we'll be using git checkout index command. So let's see what it is. Let's go into the command checkout index -a. What will happen? It actually moved to the content now from the staging area to working directory. So for that, what you can quickly check the status, and you see like changes to be committed. So two new files actually coming up. So this particular file git file tree.txt is basically untracked, and we have certain new files came up, which is the first file and second file. And obviously we need to recommendation would be like git add. So this command we have to use to make this file tree as kind of a just kind of tracked by the git repository. Now it is basically untracked yet. So use the git add and then file to include in what will be committed. Okay, so what I'll do is eventually I would like to remove the because if I just put ls la command, you see this first file tree and first file both, right? First file, second file, this both came up inside the main working directory. At this moment you see this was not before, and now it is available, and you can just write cat file first file, and you see this command, and cat second file, and you see the content. That's pretty awesome, right? And actually it's actually moved into, but it's not yet committed. So let's do this commit now. Now to uh, remove the confusion, so let's remove the file tree, this one, because we don't need it. So now if I just check once more, we have the working directory, only the first file, second file, right? And if I just check the git status, you see that no more untracked things, and we have only this particular no commits done yet. So we have to just make a commit on our git changes to our for our working directory. Now before committing the changes, you have to do one important thing, and that is you have to set up your git config with the user ID and the email ID, because this is the two things actually that GitHub uses for tracking what your future file repository or object changes. So that's why the command should be git config -- global, because global I would like to set this thing user dot name, and that probably, so user dot name, and you have to just put I just put my name, right, developed by Som. And the another command is like git config, okay, -- global, then user dot email, and you just write okay. So I just set my username and the email ID at the config level. So let's check git minus minus list. I think git config minus minus list. Yeah, git config. And if you just thoroughly check, you have this username developed by Som and email ID somnath.sap202, right? So this email ID and the username should match with your GitHub account. So if you don't have a GitHub account configured, so before you try this option, you ensure like you have also the same thing, or maybe you can do it later on as well. No worries. But make sure like this email ID and your user ID should match with your Git account. Okay, GitHub account, not Git, rather GitHub account. So pretty fine. So let's next is the commit that we need to do. So what we have to do, the command is git commit -m for message, and I can write my first commit. Okay, enter. So now two files changed, and you see like it's first file and second file that basically gets committed. And if we just quickly check the git status now, what happens? And see, nothing commit, working pretty clean. Perfect. So we have basically started all the way from creating files, folders, creating all the algorithm uses to create the different SHA objects, hash objects. We have seen how to put everything into a tree object so that it points to different files. And finally, we put that content into staging areas using the git read tree command, correct? And once it's there, then we see like the command to put that changes into working directories. But finally, we actually put into our working directory, and the commit the command that actually I have used is basically git checkout index, right, -a. So with that, we basically moved all the files from staging files, mean to say like from git repository to staging, and from staging to working directory. We have checked the git statuses and we found the certain commit is pending. Then we use our explicit git commit command to actually move the clean the tree, clean the path, enter path, and the enter files now have been put into this particular working directory. So if I make any changes in this particular any of the file, again my git status will be saying something is not tracked. So I hope like you at least got some fair enough idea like how behind the scene actually git works and how it stores the different file contents. And definitely a lot more things can be presented, but I thought like to give you a fair enough quick idea. And we'll continue certain more on this git discussion, maybe subsequent episodes. So stay tuned, and thanks for watching. I hope like you enjoyed this discussion and it was quite informative to you. So yeah, we'll again connect soon with a different topic, maybe altogether in git or maybe something else around. Let's see.